Welcome guys to today's class. In today's video, we want to discuss another experiment very important in physics, and that is determination of focal length and nature of images formed by convex lens. We have convex lens which we call converging lens, and we have concave lens which we call diverging lens. So this video or this experiment will focus on determination of focal length and nature of images formed by what? Convex lens. It has the objective as shown on the board to determine the nature of image formed by converging lens and focal length of that converging lens. Look at the apparatus setup. This is the object. This is the ray boss. The object is taken to be a broom. A broom. Yes, a broomstick. This is the lens holder. This is the lens itself. This is the image. And this is the screen. This is the table stand where the whole thing is being set up, and this is the meter rule. Now look at the procedure. The procedure goes this way. Place the lens on the lens holder and use it to project an image of the window or a light source as far as 10 meters or more from the lens on the screen by adjusting the screen until a sharp image of the object is obtained. Measure and record the distance VO of the screen from the lens. That is one. Once we get that VO, we note it. Place an object, say a broomstick, over the hole of the ray boss and set up the ray boss, lens and screen as shown in diagram above. Adjust the height of the lens, object and screen so that their heights are the same. Place the screen at a distance of 110 cm from the object. Place the lens on holder very close to the screen and move the lens away from the screen until a sharp image of the object is observed on the screen. Record the distance of the object from the lens as U and the distance of the image from the lens as V. With the screen and object at the same position in 3. With the screen and object at the same position in this II. Move the lens closer to the object until a sharp image is formed on the screen. Again, record U and V. Repeat 2 and 3 for D equals to 100 cm, 90 cm, 80 cm, 70 cm, 60 cm. Tabulate your results. Now, the essence of this experiment we are demonstrating this day is to see how you can perform this without touching apparatus, okay? And so we want to go into how do we get our table of values without us bringing this equipment and start demonstrating it. So we call it operation don't touch apparatus. Yes, we want to perform it without touching the equipment, so to speak. Okay, let's see how to do it. Now, the essence of the first procedure is for us to get our VO, which will be called the focal length of that what? Convex lens. That is the essence. Now, because this convex lens has a range, the focal length of a convex lens has a range, we will not waste our time doing it because we are trying to perform it without touching apparatus. So what we will do is I will say the range of focal length is equal to 13 to what? 15 watts. The focal length of a convex lens ranges between 13 to 15 cm. Now, what we do is I will pick a value here as what we will be using. I pick 14 cm, but it must be in this range. Okay. Then, what I will remember is that they said G is 100 and what? 10 cm. And the D they mention here simply mean D equals to the distance of the object plus the distance of the image. That is what they say it is 100 cm. 110 cm. And so we say 110 is equals to UD plus what? VD. We can make U the subject of formula. We say therefore UD equal to 110 minus VD. Okay? And you still remember that our length formula is 1 over this plus 1 over what? V. Okay? Where U is 110 minus VD, we say 1 over F equals to 1 over 110 minus VD, where the 110 is your D. So let's still put it as our D. But we should know that in this case, 110 is your D, 100 D, 90 as they say in the procedure. Then plus what? 1 over what? V. Looking for LCM, you'll be having that 1 over F is equals to D minus VD and VD. This divide this will give me VD plus this divide this will give me D minus VD. And so this will cancel this, leaving you with D only, right? So this times this will be what? VD dVD. This VD means image distance. Are you getting it? Image distance. So we have to make it to be very tiny. Okay? This times is minus VD squared. Then this is D equals to 1 over what? F. So we now say cross multiply this times this will be what? FD equals to dVD minus VD squared. And so what we'll be having is, we will now say take this to this side, we have VD squared. Take this to this, we have dVD. Then take this, this is here, this will remain here plus FD equals to 0. So we'll be using this formula to do our what? Solving. Solving this using quadratic equation. Resolving this using quadratic equation, we have ax squared plus bx plus c equals to 0. This is 1. That means our a equal to what? 1. Our b equals to minus d. Our a equal to 1. Our b equal to minus d. And our c equals to fd. You can see a1, b minus d, c, fd. We have gotten what we are to use to solve. We are trying to make v subject of formula vd, because this is like s squared x. So we are trying to make v subject of what? Formula. So resolving vd squared minus dvd plus fd equal to 0 using quadratic formula. We will be saying that where a is 1, b equal to minus d, and c equals to fd, we will be having that vd equals to VD equals to minus bracket minus D plus or minus square root of what? B square minus what? B square is what? Minus D squared minus 4 times 1 times what? C FD all over 2 times 1, 2. So we have it to be VD equals to D plus or minus square root of D square minus 4FD all over what? 2. Okay, so we'll be taking the one of minus, you get, so that we can get the value of VD. Okay, someone can take the value of plus, someone can take the value of minus. Are you getting it? But I decided to take the value of minus. Once I'm able to get the one of VD, I'll subtract it from the total, which is the value of D. Once I subtract it, I get the one of U. Since we said that U plus V is equals to D. Okay? So I'm using minus here. I'm using minus here. So to get it, I will be saying VD equals to 110 minus square root of 110 squared minus, let me package it on top of here. Okay, so we'll be using the one of minus. You know that the possible value for D is D plus this all over 2 or D minus this all over 2. That doesn't mean you can't use plus. If you use plus, whatever it gives you, you minus it from 110 to get your what? UD. But if you are using minus, whatever it gives you too, you minus it from 110 to get your what? VD, to get your UD as well. Since we said that U plus V is equals to D, which could be 110, 100, 90, 80, and all have you. Okay, so I am putting now 110 minus square root of 110 all what? Squared minus 4 times F. I'm taking my F to be 14 times the 110 all over what? 2. I will use my calculator to sort it out. I'll say 110 minus bracket square root bracket 110 squared 4 times 14 times 110 divided by 2. That should be giving me 16.5. I will say 16.5 cm. I'll make it to be in 1 decimal place. Are you getting it? I'll make it to be in 1 decimal place. I'll make it to be in 1 decimal place. The reason being that if I make it to be in 1 decimal place, the centimeter rule we use as a measuring instrument, the reading accuracy is like 0.1 cm. Like the minimum we can get from it is 0.1. That if you get to 0, get to 1. If you get to what? 0, get to 1, get to 2. Here 0.1, 0.2, 0.3, 0.4. That means you can get only 0.1 cm as the reading accuracy of it. So this is like 16.5. So if you say 16.51, 52, 53, you can't get it with your what? Ruler. Highest you can get is 16.55. That is in between 16 and 17. Are you getting it? So that is how it goes. Remember we said first thing compute the inside own, and that's why I say square root of bracket 110 squared minus bracket 4 times 14 times 110, then minus, so we are correct. So we change this 110 to what? 100. They said for 100, 90, 80. We change it to what? 100. We follow the same pattern. So we'll be having square root of okay, 100 minus bracket square root of bracket 100 squared minus bracket 4 times 14 times 100 divided by 2. That will be giving me 16.8. Let's check it again. 100 minus square root bracket 100 squared minus bracket 4 times 14 times 100 divided by 2. 16.8. So if we change it, you have 16.8 cm. That means it's increasing. Are you getting it? Then we go again. We say that we have to change here to 90. Change here to what? 90. Change here to what? 90 according to the formula. Okay? 90 minus square root bracket 90 squared minus bracket 4 times 14 times 90 divided by 2. You have 17.3 cm. Then we change here to what? 80. Change here to 80. We say 80 minus square root bracket 80 squared minus 4 times 14 times 80 divided by 2. We have 18.1. Are you getting it? Then we'll go again. Change here to what? 70. We change it to 70. We say 70 minus square root bracket 70 squared minus bracket 4 times 14 times 70 divided by 2. We have 19.4. 19.4. So we fill our what? VD. We fill it. Our V is 16.50, 16.80, 17 point, and 16.50, 16.80, 17.3, then 18.10, and what? 19.40. Okay, we have gotten the values of v as we have seen on the table. We notice that u plus v is equals to d. As they said, the object distance plus the image distance will give you d. Therefore, we say that u will be equals to d minus v. So we have to subtract all our d. The first d is 110.00, 100.00, 90.00, 80.00, and 70.00. Okay, so our u will now be equals to, we say this minus this, 110 minus 16.5, 93.5. You have here to be 93.50. 100 minus 16.8. This is 83.20. 190 minus 17.3. This is 72.70. Then 80 minus 18.1. This is 61.90. Then 70 minus 19.40. This is 50.60. You have seen the actual number is in one decimal place because of the meter rule we are using. Centimeter rule is in 0.1 cm. That is the least value you can get from it. And so we are just attaching the other zero to beautify the values. Now we get the inverse of u. Inverse of u is 93.5 inverse equals to, we'll be putting it in 3 decimal place. It will be 0.011. 83.2 inverse 0.012. 72.7 inverse 0.014. 61.9 inverse 0.016. 50.6 inverse 0.020. Then inverse of v, 16.5 inverse 0.061. 16.8 inverse 0.060. 17.3 inverse 0.58. 18.1 inverse 0.055. And 19.4 inverse 0.052. So we have gotten our table of values for the experiment. Yes, we want to go into the what? Graph plotting, so that we'll see how we can plot this graph. See other questions that will follow it. Are you getting it? That is what we want to go into now. How to do our graph, see other questions that they want us to do, and see how to what sort those questions out.